Good day everyone, welcome back to our discussion on the topic forces, and today we will be discussing resolution of forces. Now, for resolution of forces, this is a reverse process of the resultant of two given forces we've treated earlier. Here we resolve a given force into two parts which are known as resolute, that is along the y-axis which is the vertical and along the x-axis which is the horizontal. Also, when we resolve force, we are to take note of the inclination or direction of our forces, that is the angle theta. And when we resolve forces, we mostly take the angle to the horizontal for uniformity. Now, for any given forces F that acts at an angle theta to the x-axis as shown below, the Fy is the vertical component and the Fs is the horizontal component. And using simple trigonometric ratio, Fs over F will be equals to cos theta, which will make Fs to be equals to F cos theta, and Fy over F will be equals to sin theta, which will make Fy to be equals to F sin theta. Also note that tan theta will be equals to Fy over Fs, which will make theta to be equals to the arctan of Fy over Fs. And by vector notation, I stands for S and J stands for Y, so F will be equal to F of Si plus F of Sj. And note, when we are resolving, we take note of the direction of our coordinate. That is, if our S is facing the negative S direction, it will take a negative symbol, and if our Y is facing the negative Y direction, it will take a negative Y symbol. So if our S is facing the negative S direction, F of S will be equal to minus F cos theta, and if Y is facing the negative Fy direction, F of Y will be equal to minus F sin theta. And also remember that we are always taking our angle with respect to the horizontal. We have an example that states that find the horizontal and vertical component of the force below. Now, for our horizontal component, we deduce that F of S will be equals to F cos theta. So therefore, F of S will be equals to 6 cos 45, which is equals to 3 root 2. And for our vertical component, F of Y will be equals to F sin theta, and F of Y will be equals to 6 sin 45, which is also equals to 3 root 2. And remember, we always take our angle to the horizontal. Our next example states that find the horizontal and vertical components of the force below. Now, as you can see, our F of S, that's our horizontal force, is facing the negative direction. So therefore, it will be taking the negative symbol. So F of S will be equals to minus 10 cos 30, which is equals to minus 5 root 3 Newton. And our F of Y will be equals to 10 sin 30, which is equals to 5 Newton. The reason we are doing this directly is because our angle is to the horizontal. We have another example that states that find the vertical and horizontal components of the force F, which is equals to 200 Newton and 030 degree. Now, our very first step is to sketch our curve, and doing so we get the diagram as shown on the screen. Now, for our horizontal components, we know that F of S will be equal to F cos theta, which make F of S to be equal to 200 cos theta, which is equals to 173.2 Newton. And for our vertical component, F of Y will be equals to F sin theta, and F of Y will be equals to 200 sin 30 degree, which is equals to 100 Newton. Our final question is from NECO 2004, and it states that the vertical component of a force F, which makes an angle of 25 degrees with the horizontal, is 60 Newton. Find the magnitude of the force. Now, our very first step is to sketch out our forces, and when we do that, we get the diagram as shown on the screen. Now, since we are given our vertical components, we are going to be looking for our force F using the vertical component. Now, recall, F of Y divided by F is equals to sin theta. Now, substitute for F of Y and sin theta. 60 divided by F will be equals to sin 25 degree. and cross multiplying, that is to make F the solved formula, F will be equals to 60 divided by sin 25, which is equals to 141.97 Newton, and the correct option is E. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.